All right, talking about divisibility. We've got divisibility rules for almost all the numbers 2 through 10. Divisible by 2 means it ends in an even. Divisible by 3 means that if you add up all the digits, they add up to something divisible by 3. Divisible by 4, we have to look at just the last 2 digits. So that's what we're looking at right here. The last 2 digits. If that is divisible by 4, so if 88 can be divided by 4, then the whole thing can be divided by 4. 88 can be divided by 4. So yes, it's divisible by 4. Continuing those, divisible by 5 means it ends in a 5 or a 0. Divisible by 6, kind of a lame kind of rule, but it just means that you can divide by 2 and 3. So you check the 2 rule and you check the 3 rule. If they both work, then 6 works. So the rule for 2 is that it's even, so it ends in a 0, 2, 4, 6, 8. Yes, it's divisible by 2. Also has to be divisible by 3. The rule for 3 is that you add up all of those digits, 1 plus 9 plus 7 plus 6 plus 2. That's 10, 17, 23, 24, 25. Is 25 divisible by 3? No. So since it's not divisible by 3, it is not divisible by 6. For 6, it has to be a yes to both the 2 and the 3 rule. There's no rule for 7. 8 is kind of like the 4 rule, but you go out to 3 digits. And then 9 is the same rule as 3, except the number has to be divided by 9. Those are all your divisibility rules. Prime factorization, that just means that we are dividing. So when I do these, I do the factor tree typically, but you're just dividing. What divides into this? So since it ends in 0, 0, that's 100 times 58. And you keep breaking those numbers down. 100 is 10 and 10. 10 is 2 and 5. And you keep going until you can no longer divide. 2 and 5 are prime. They can't be divided by anything. So we stop at those prime numbers. 58 ends in an 8, so that's 2, and that'll be 29. And 29 is prime. It's just a bigger prime number. So the prime factorization is you write out all of these numbers. Just doing this gets you them, but now you write them out. We got a 2, another 2, and another 2. So 2 times 2 times 2. And then a 5 and a 5. And then the 29. Write them all out. That's prime factorization. If you wanted to get, I don't know, I guess lazy, maybe, you could write 2 times 2 times 2. You could just say that as an exponent, 2 to the 3rd, 5 squared. It's less writing. Doesn't matter. Either way is good. For 90, we do the same thing. That's 9 times 10. 9 is 3 and 3. 10 is 2 and 5. So that is 2 times 3 times 3 times 5. Or you could have said 3 squared. Those are both good. With or without exponents. Greatest common divisor. Well, these numbers are pretty small, so that's going to be pretty easy. You might automatically know that the answer is 4, because 4 goes into both of them. That's the biggest number that goes into both of them. The other, you can go down to the prime factorization. The easiest, this calculator doesn't do it, but most of yours do. When you go to option, number, there's more options than this on your calculator. You can scroll over to GCD. You type in the 2 numbers. 8, 12, hit enter, and the calculator will tell you that the answer is 4. That's an option number. Then you scroll over until you see GCD. Right next to GCD, there's an LCM button. You do the exact same thing. And in your calculator, you type LCM 112, 96. And if you put it on your calculator, it'll say 672. If you're not able to do that, you can do that with prime factorization. It takes quite a bit longer, because you have to get the prime factors of 112 and 96. So you have to do what we did on the previous page. For 112, that's 2 and 56, 2 and 28, 4 and 7, 2 and 2. So for 112, it's 2 times 2 times 2 times 2 times 7. And then 96 is 2 times 48. 48 is 6 times 8. So for 96, it's 1, 2, 3, 4, 5 2s. And a 3. So that's your prime factors. As you're going through LCMs, you have to write down everything. So LCM is going to have a 2. We can cross out a 2 from each one. Another 2. Another 2. Another 2. Still has to have another 2. Then it has to have a 3 and a 7. And if you multiply all of that together, you get 672. That's the LTM. The GCD, if you did that the same way with the prime factors, you would go, and this example is too short. You just take what they have in common. So they would have 4 2s in common. That would be the GCD. Part of the GCD would have the 4 2s. And that's the only part they have in common is the 4 2s for this answer. All right, evaluate the expression. Remember, you do parentheses and brackets first. If you type this in exactly as it is, directly into your calculator, it'll work. Or you can just go through and do the orders that you know. So negative 15, negative 67, that would be negative 82 for the brackets here. 81 minus or plus negative 65 is minus 65. That's 16. Negative 82 plus 16 is negative 66. For adding, subtracting, since there's no parentheses, we just go left to right. So negative 21 plus 14 is negative 7. Plus negative 23, that's negative 30. Parentheses first on this next one, that's 43. That's 6. There's a minus in between. 43 minus 6 is 37. Multiplication, negative times negative is positive, so that's positive 12. 8 times negative 8 is negative 64. And this is multiplication in there. That is larger than I can do in my head. 12 times negative 64, negative 768. Nine times 9 times 9, and it's negative times negative times negative, so it's going to be a negative answer. 729. Negative 259 divided by 37 is negative 7. And then this last one, 6 divided by negative 2 is in brackets, so that goes first. That's negative 3. And then we have a negative 7. 3 times 7 is 21. Negative times negative is positive. Reduce the fraction. Also easy using the calculator. You can just type it in as a fraction. 102. Here's your fraction button. The A, B, C button, that's fractions. 153 is your denominator. And it will automatically reduce it to 2/3. Alternatively, you just divide by the greatest common divisor, or just keep dividing whatever goes into it. 102 and 153, they can both be divided by 3, so you'd start with that, and then divide over and over and over again. Convert a mixed number into an improper fraction. That means you're multiplying, starting at the bottom, going around clockwise. 12 times 23. We get an answer, and then we're going to add 20. 12 times 23 is 276. And then we add the numerator to that. That is 296. That's our numerator. The denominator is 23. It's the improper fraction. Converting an improper fraction to a mixed number. If we type it into the calculator, I think this leaves it alone, so that doesn't help us out. So what we can actually do is, when you reduce this, you take the denominator away from the numerator. You subtract it over and over and over again. We can only subtract 71 from 83 one time. And if you subtract it away, you'd get 83 minus 71 would be 83 minus 71 is 12. So that's 1 and 12 71sts. The other option for this, actually a little bit less thinking, is you just type it in as division. 83 divided by 71. Not the fraction, but the divided by. It gives you a decimal. So that 1 point whatever tells us the whole number part. Then subtract it, whatever that whole number is, subtract 1. So we don't have that. So we have 0 point whatever. And then press the S to D button, and it'll change what's left over to a fraction, 12/71. Subtract the whole number away, change the rest of it back to a fraction. Or do it by hand. Fraction to decimal, it's just division. Once upon a time, you may have been taught how to do this by hand. Just use your calculator, though. It's so much easier. 0.857 142. And it goes back to the 8571. So it's actually 7 actually repeats. It's those 6 digits over and over and over again. .25 to a fraction. Type it in, 5.25. And then you can press the F to D button. 21/4. If you wanted it as a mixed number, you just wouldn't type in the 5. The 5 would be your whole number part. The 0.25 would be 1/4. Either way is correct. They're both fractions. Repeating decimal, 0.704 repeating. Really simple trick I taught you guys with this is you write the part that repeats and you put it over 9s. Whatever repeats is going to be over 9. So since there's 3 numbers here, it's got to be over 3 9s, over 999. And super easy to check is you just type it in, 704 divided by 999. 704, 704, 704. That's it. Multiplying fractions, you can also just type these into your calculator, but multiplying fractions is super easy. You multiply straight across the top, straight across the bottom. 7 times 9 is 63. 3 times 5 is 15. This will reduce because of something you learned way back in elementary school. You can actually cross-reduce these problems. This 3 can reduce, this 9 can reduce. It'll make it an easier problem that you would reduce early rather than late. 7 times 3 is 21. 1 times 5 is 5. That's actually the reduced fraction. Or you just type it in with the parentheses and all. 7 over 3 is a fraction. And then negative 9 over 5 as a fraction. Negative 21 over 5. Calculator does it too. For division, you can just type it in, but what division is really is multiplying by the reciprocal. You flip the second fraction. If you follow the same rules as before, the 2 and the 20 can be reduced before you multiply straight across for multiplication. 10 over 9. Or type it straight into your calculator. It gets it too. Parentheses, we have to do the parentheses first. So negative 1/6. Division, we're going to change that to multiplication. Flip it. You can cross-reduce here. The 6 and 10 can both be reduced by 2, so that goes to 3 and 5. So negative 1 times 5 is negative 5. 3 times 3 is 9. And we got the 1/5 here, and that's a division symbol. So that means we need to change it to multiplication and flip the second one. 9 over 5 when we flip it. Nothing reduces when we look at our cross-reducing here. So that's negative 9 over 5 times 5. Does not reduce. Again, you could have used your calculator to help you through that. Adding and subtracting fractions, you need common denominators. They have to have the same denominator. This is, in my opinion, it's worth getting out a calculator for, because getting common denominators for 18 and 30 is going to be kind of big numbers. when you can just type it in, 11 over 18 minus 7 over 30. Get an answer. Typically, I didn't do it here, but I almost always recommend that each fraction you write it inside parentheses. It helps you see the fractions better. Prevents little calculator errors. 11 over 18 minus 7 over 30. It's still the right answer, but when I type in fractions, I always recommend parentheses. So this one's easier. I'll do this one by hand because common denominator is just 20. So this needs to get multiplied by 5. So that's the numerator. So that's 15 over 20 plus 3 over 20. That's 18 over 20. Just add the numerators. It does reduce now. Divide them both by 2. You get 9 over 10. Or type it into your calculator the same way. Doesn't matter. Evaluating, now we've got division and addition. We have to do the addition first because it's in parentheses. They have the same denominator. Super easy. That's 9 over 7. Just add the numerators. Now, since it's division, we keep the first one, change divide to multiply, and the second fraction gets flipped. Easy simplification here is the 9 on top, 9 on bottom. Those cancel out. Final answer's 7 over 5. Again, you can type it into your calculator with the fractions, use parentheses around them. It'll work out. You do have to practice that, though, if you're going to do that. Decide if the number is rational or irrational. It's not even asking us to simplify. It's just saying rational or irrational. Rational numbers inside a square root mean that they will get you a whole number answer. They will work out. The square root goes away. So if you can do the square root of 225, then it's rational. And you can because that's 15. $194, that one will not simplify. It's going to give you a decimal. Irrational numbers are decimals that never stop, they never repeat. So that's irrational. Evaluate the expression. For these, I, again, would just recommend typing them in. There's a negative there, so it's going to be a negative answer. You type it in, negative square root of 100 is negative 10. If it's an answer that you know the square root of 100 is 10, then good. Saves you time. You don't have to pull out your calculator. 324, same idea. Negative in front, square root 324. Again, it simplifies perfectly. It's negative 18. Depending on your calculator model, they will, all calculators will simplify these. Only the newest Casios and stuff will simplify these for you. This one on my computer is not the newest. So when I type this in, it's actually kind of useless. It does not give me the answer. Some calculators will. When you type it in, it will tell you the automatic answer, and that's super easy. If you don't have a calculator that will simplify it for you, you have to do the prime factorization. 432 can be divided by 2. That would be 2 and 216. What a different way to do this is you can always check this new number here, 216, and see if it has an answer. It doesn't, so then break it down again. So let's just break it down all the way. 2 and 108, 2 and 59. Anything going to 59? Divisibility rules, 2 does not go, 3 does not go, 4 does not go, 5 no, 6 no, 7 doesn't work, 8 no, 9, can't think of anything. So I think 59 is prime. So this breaks down to 2 times 2 times 2 times 59. Now, when you get your prime factorization, you're just looking for 2 of the same thing. When there's 2 of the same thing, that's the number that goes in front. Whatever you do not have 2 of the same thing, 2 and 59, goes back on the inside. And when you're doing it this way, I would always check. There's square root of 432. It's 20.78. Check your final answer that you're writing down. 2 square root 108. Make sure that they match. 20.784, 20.784. I wrote 59 instead of 54. 54 does break down, so there'll be another number in here. 2 and 27. 27 is 3 times 9, and 9 is 3 times 3. So let's write all that down. 2, 2, 2, 2, 3, 3, 3. That just means we weren't simplified all the way. Good. Going back, we circle our pairs though. 2 and 2, 2 and 2, 3 and 3. Stuff that we circled gets multiplied together. 2 times 2 times 3. It's 12. 3 goes back on the inside. So, still the same check. We weren't wrong before, but we were not simplified all the way. 12 square root of 3 should work out to be that same number, the 20.78. 20.78. Again, you save yourself all that work if you have an upgraded model of the calculator. Might be worth getting. At 325, you go through the same process. 5 goes into that. I better check my division with calculator since I can't divide this morning. 5 times 65. 5 goes into that again. It's 5 and 13. 13 is prime, and I didn't mess up on my dividing this time. So 5, 5, and 13, those were our numbers. If there's a pair, goes on the outside. The leftover goes on the inside. Check your final answer, 5 square root of 13. Is that the same thing as the original problem, square root of 325? Yes. Here's another one that is super, super easy with an upgraded calculator. Otherwise, you have to simplify them and combine them, and it's kind of crazy. So, square root of 5, I know we cannot simplify. The square root of 20, we have to simplify the same way as those last problems. 20 is 5 times 4. 4 is 2 times 2. Circle your pair of 2's, it gets to come out. The 5 is left over, it goes in. When you bring out the 2, there's already a 5 outside. You have to multiply. 5 times 2 gives you a 10 outside. Now when you add or subtract square roots, they have to have the same square root part, like square root of 5. Then you just do the math with the outside numbers. -7 minus 10. That's -17. Then you keep the square root of 5. Again, the upgraded calculators, especially Casio's, do this. Just type it straight in and it'll do the entire thing for you. Same idea here, 7 square root of 128. That's 2 times 64, 2 times 32, 16 times 2, 8 times 2, 4 times 2, 2 times 2. It's a whole lot of 2's. We need them 2 at a time to come out. So 2 and a 2 comes out. 2 and a 2 comes out. 2 and a 2 comes out. We have 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. That is 56. Leftover 2, that goes back in. 162, that's 2 times 81. 81 is 9 times 9. These are not, 9s are not prime, but you did get a pair. That's all that actually matters, is you got a pair, 9 and 9. 9 times the 2 that's already there is 18. That leftover 2 goes back in. Since the square root parts match, you just do the math with the outside. 56 minus 18. 38. Keep the square root part. Multiplying square roots, you multiply the numbers on the inside. 26 times 10 is 260. And then we're going to simplify, which means break this down. Well, that's 26 times 10. That's how we got it. That's 5 times 2. This is 2 times 13. Those are all prime numbers. Nothing else breaks down. So we do have a pair of 2's. So 2 comes out. We have a leftover 13 and a leftover 5. You got to multiply those back. That's 65. That's it. That's simplified. Again, type that into your calculator. If it's the upgraded next model, it does it all. Just like here, we multiplied the numbers. Here we can divide the numbers. 24 divided by 6. That's 4. And then we have a square root of 4. The square root of 4 is 2. Final answer. That's it. Or type it into your calculator. It can do it. Even if your calculator is not upgraded, this one it can do. Since it worked out to be a whole number, it would have worked out. It's just when they don't work out to be a whole number, this calculator can't do it. Rationalize the denominator means we have to make the denominator be a perfect square, whatever that takes to be a perfect square. So 15, the only thing that can make that become a perfect square is if you've multiplied it by 15. So that's 15 square root 15 over square root of 15 times square root of 15. This is a lot of work that you actually don't need to do. 15 times 15 is 225, and then the square root of 225 is going to be 15 because there's two 15s right there. 15 over 15, since this is a fraction, looking at the whole numbers, 15 divided by 15, that cancels out. That's 1. Our final answer is just square root of 15. Now, whether or not you have an upgraded calculator, it's always a good idea to check the original problem, 15 divided by the square root of 15, and compare that to our final answer, which was just square root 15. Make sure that they're the same thing. Otherwise, you messed up somewhere and you go back and fix it. Easy way to check your work. All right, so this next one, you can make 8 be a perfect square without multiplying by 8. You can multiply by a smaller number if you think of it. If not, you can do the 8 and it'll work out. But if you just multiply by 2, that makes square root of 16, which you can do. It makes it a perfect square. So that's the square root of 10 over the square root of 16, which is square root of 10 over 4. And that's it. Square root of 10 does not simplify, so that will be your final answer. If you multiply it by something larger than 2, you just have a fraction to reduce here at the end. Works out the same way. This is naming the properties. The 3 properties we talked about are commutative, associative, and distributive. Distributive, you guys usually are pretty good at because you use it by name all the time in algebra. You're looking for multiplying with parentheses and addition, which is right here. That's the distributive property. The other 2, commutative and associative, well, we talked about them. Commutative, root word commute, like travel. So when you move things, you're traveling. So look for the one that has traveling numbers. Not really either of these. These travel a little bit. Went from 1, 6, then a 2, to a 6 and a 1, and then a 2. So the 2 stayed put, but the 1 and the 6, they did switch around. They did move. So that is the commutative. The 1 and the 6 switched places. They commuted. They went to a school and back to home. The last one is associative, and that's when you group things differently. Who you associate with, your associates, your friends, your group. So here this regroups with parentheses. The 4 and it's the same 3 numbers in the same order. So it's not commutative. Same 3 numbers, same order. But instead of grouping, first time we grouped 4 and 8 together, the next time we grouped the 8 and the 6 together. That is the associative. Rules for exponents. When you're dividing, you subtract exponents. When you're multiplying, you add exponents. We are dividing, so we're going to subtract exponents. It's actually the exact same thing on top and bottom. Anytime that happens in a fraction, the answer is 1. Or you could have done 9 minus 9 is 0, and anything to a 0 power is 1. That's a different exponent rule. Multiplication, you add exponents. -1 plus 4 is 3. It says, and then evaluate. So 3 to the 3rd. 3 times 3 times 3 is 27. 43, same property. We're multiplying, so we're going to add exponents. And then you can work that out, -2 to the 7th. You might want a calculator, use parentheses. The little caret right there is your exponent. You get -128. Then when you have a power to a power, you multiply them. So that's 4 to the -2. And then to evaluate it, negative exponent means it goes to the denominator. 4 squared is 16. That's the most simplified final answer. Scientific notation. Number one thing to remember is that it's one digit, then the decimal, and then any other non-zero digits. So 3.5 is going to go to 3.5. Now, to move the decimal there where it needs to go, from where it started, we had to move it 1, 2, 3 spots. It's going to have a 3. Last thing to think is that a +3 or a -3? Negative exponents are decimals. Negative exponents are small numbers. This was not a decimal. This was a big number, so that's correct. It's positive exponent. Next one is one digit, then the decimal, so 2 point, and there won't be anything after that point because there's no other digits. Count how many spots we have to move it. 1, 2, 3, 4, 5, 6, 7. Now, if we left this positive, that's talking about a big number, just like the previous problem. So it needs to be a negative exponent because it's a decimal. And yes, you can always try typing these things into your calculator and see if you get the original. Sometimes it'll display weird, but it's worth checking. (8.5 times 10 to the 5th). Since that's a positive exponent, this is going to be a large number. So it's got to be 8, 5. And we're moving it 5 spots total. From here, we're moving it 1, 2, 3, 4, 5 spots total. Fill in the zeros. 850,000. 850,000. 9 times 10 to the -7th. -7 means it's going to be a decimal final answer, a really small final answer. The decimal started after the 9. We need to move it to a decimal number, a small number. We're going to move it 1, 2, 3, 4, 5, 6, 7 spots. Fill in the zeros. All right, doing math with scientific notation, you multiply the numbers. 2.8 times 3. And then we follow exponent rules with the times 10. It's multiplication, so we're going to add exponents. 3 and 2. -3, -2 is -5. Hopefully you don't need to do any moving after this, and we don't. It's one digit, then the decimal. We're good. Same beginnings here. 2.4 divided by 3. We start with the numbers. 2.4 divided by 3. 0.8. Unfortunately, that's going to have to be adjusted here in a second. Dividing, so we subtract the exponents. -9 minus -4 turns to plus. And we get an exponent of -5. So that is not our final answer because the decimal needs to be there. So we have to move it 1 spot. So that means we have to change this by one number. It's going to be 8 times 10. Now, the way that we moved this, it might be confusing. It is a little bit confusing. So what I do when in doubt is I just write this original problem. 0.8 times 10 to the negative fifth means we're moving it this way. 1, 2, 3, 4, 5. Because negative means it's got to be a decimal. And then we're going to take that answer and we're going to change it back into scientific notation, moving it 1, 2, 3, 4, 5, 6 spots to put it where we need it. Since we moved it 6, that's got to be a negative 6. If you get confused, just draw it out and draw the little humps to keep track of it. Your calculator can do some of this stuff. If you type this in, it'll help out a little bit. Here's a little 10 to the exponent. I need the times, I don't think so. So that's scientific notation. And you can divide it by the other one. 3 times 10 to the negative 4. And it does give it to you. You just got to find your little times 10 to the power button. Sometimes it's written on your calculator as that E, or maybe EE. I don't know why. I think it's made by monkeys. EE. Yeah. All right. For all the sequences, we'll give you the formulas for them. Write the first 5 terms. We don't really need a formula for this one. Write the first 5 terms. You just have to know that D means that's what it's changing by. It's going to arithmetic, so it's adding 5 or 8 each time. I can't read. Adding 8 each time. So the first term is 2. Start with a 2. Add 8 over and over and over again until we write out 5 terms. Add 8, get 10. Add 8, 18. Add 8 again, 26. Add 8 again, 34. 1, 2, 3, 4, 5 terms. That's all. Arithmetic means add. Arithmetic. So again, this is an adding sequence. You can see that it's adding 5 each time. So that's D is 5. Writing an expression, that is the formula. Arithmetic sequences, the formula is this. A1 plus D n minus 1. We just found D was 5, so 5 goes there. N minus 1 always goes in the parentheses there. That never will change. A1 is 2. There's your formula. Or expression, it says. Same thing for this next one. You have to look at how it's changing. This is increasing from -6 to -9 to -6 to -3. It's adding 3 each time. So D is 3. Take your same formula. A1 starts at -9 plus D, which is 3, n minus 1. The sum of the terms of the arithmetic sequence. Remember, that's what we talked about. If you had the whole list of numbers, you fold it in half, they match up, you get a whole bunch of numbers that make the same thing. Or the formula is, you take the first one, you take the last one, you multiply it by n, and divided by 2. The divided by 2 is the folding in half part. So A1 is negative 15. AN, that's the last number. That's 81. They tell it to you right there. N is 17. And it's always divided by 2. So on your calculator, just type it in. Negative 15, do parentheses first. Times 17 divided by 2. 561. Geometric, that means multiplication. It's a multiplying pattern. Arithmetic means add, geometric means multiply. So that means each time we're multiplying by 3. So these numbers get large quickly. Starting at a negative 5, we're going to multiply by 3. Negative 15. Multiply by 3. Negative 45. Multiply by 3. Calculator time. Negative 45 times 3. Negative 135. And then times 3 again is negative 405. First 5 terms, 1, 2, 3, 4, 5. General expression for the geometric sequence. This is your formula. I'll write it on the board or I'll give it to you for the test. A1 is 2. That's easy. R is what are you multiplying by each time? 2 to get to 6, we have to multiply by 3. Double check that that works. 6 times 3 is 18. Yes, 18 times 3, 54. Just make sure you have the correct R multiplication number. Same question. Again, that formula is A1 times R to the n minus 1. To get from negative 3 to positive 6, negative 3 is A1. But to get from negative 3 to positive 6, that means we had to multiply by negative 2. And if you check that, that works each step of the way. So there's your equation, there's your expression. The rule. You can put the AN in front. Sum of the terms of the geometric sequence. That is 1 minus R to the n over 1 minus R. There's your formula. Again, you'll be given it. A1 is 97. R is 2. N is 4. Start with the exponent inside the parentheses. 2 to the 4th is 16. So that's 97 times 1 minus 16 over negative 1. So that's 97 times negative 15 divided by negative 1. Just going to change the sign. 1,455. Same formula. Plug in A1, that's -5. Plug in R is 2. Plug in N for the exponent. Divided by 1 minus R on the bottom. 1 minus 2. Again, we start with the exponent. 2 to the 10th. So that's 1 minus 1024 for the inside of the parentheses, -1023. Divided by 1 minus 2 is -1. -5 times -1023 divided by -1. We're checking to see golden ratio. Golden ratio is about 1.6. So we're just checking to see if it's close to 1.6. Big number on top, 72.81. Divided by 45. 1.618. That's like perfect. Yes. Next one, same thing, 3.04 divided by 2.00, just 2. 1.52, that's not close enough. It's got to at least be a 1.6 something. Fibonacci type means adding the 2 previous numbers. So when you add up these 2, do you get -6? Yes. When you add up these 2, do you get -4? Yes. When you add up these 2, do you get -10? Yes. Just pick the 2 terms and see if you get the next one. And try it for most of the way through it, as much as you can. Add up the first 2, you get -2. Add up the next 2, that'll be 3. No. It's weird though, because the next one actually works. First 7 terms of the Fibonacci sequence, I start with 1. I've seen it started with 0, but I start with 1. Start with 2 ones. 1, 1. Then the next number would be 2, because you add those up. The next number would be 3, because you add those up. The next number would be 5, because you add up the 2 previous. And then 8. And then 13. 1, 2, 3, 4, 5, 6, 7. 7 terms. That's it. I'd probably still give it to you if you started with a 0. And then that would mean you stopped at 8. I'd still give that to you. And last one, to get the 27th term, to get the 27th term, you add up the 25th and the 26th. You add up the 2 previous terms. So 7, 5, 0, 2, 5, plus 1, 2, 1, 3, 9, 3. 196, 48, 418. That's it.